Hello everyone, this is Andy Boy Dihilia from Liceo Math Club. A pleasant day to all. Surely, learning is a non-stop process. And so here we are again for another math video tutorial. Today's topic for the tutorial will be exponential equations, its rules, and finding the unknowns. First, let us know what is an exponential equation. By definition, an exponential equation is an equation that involves exponential expressions in the form of b to the power of n is equals to a, where b is a positive number except 1. To put it simply, it is an equation where the unknown is not found at the base, but on the exponent itself. Examples could be 5 to the power of x is equals to 5 squared, 3 to the power of x plus 1 is equals to 81, 32 is equals to 16 to the power of x minus 1, and so on. Before we further discuss and solve these equations, let us know first the basic rules on exponents. The product rule. The product rule has two cases. First is when the equations have the same base, and the second one is when the equation have the same exponent. Case number 1. For any number n to the power of x multiplied to n to the power of y, we just simply copy the base n and just add their exponents, which results to n to the power of x plus y. Case number 2. For any numbers n to the power of x multiplied to m to the power of x, we just simply multiply the bases n multiplied to m and just copy their exponent, which results to n times m closed quantity to the power of x. The second rule would be the quotient rule. Like the product rule, it also have two cases with the same conditions. Case number 1. For any number n to the power of x divided by n to the power of y, we just simply copy the base n and subtract their exponent, which results to n to the power of x minus y. Case number 2. For any number n to the power of x divided by m to the power of x, we just simply divide the bases n over m and copy their exponents, which results to n over m closed quantity to the power of x. The third rule would be power to power rule. For any number n to the power of x raised to another exponent, which is y, we just simply multiply their exponent and copy the base, which results to n to the power of xy. The fourth rule is the zero exponent rule. Any number with an exponent of 0 will always be equal to 1. For example, n to the power of 0 is equal to 1. Lastly, the negative exponent rule. Any number with a negative exponent is equal to its reciprocal. For example, n to the power of negative x is equal to 1 over n to the power of x. These are the 5 exponential rules we need to remember in solving exponential equations. Also, we need to keep in mind the property of exponential equations, which states, if b is any positive number except 1, then b to the power of x is equal to b to the power of y if and only if x is equal to y. In other words, the property states that if both sides of the equation have the same base, then their exponents are equal. Now that we know the rules of exponents and its properties, we are now ready to solve exponential equations. Number 1. What is 3x is equals to 27? What do? First step, we need to express both sides of the equations into the same base. We all know that 27 can be rewritten as 3 cubed, which is necessary so that both sides will have the same base. Then, through the property of exponential equations, we drop down the base and equate its exponents, which is x is equals to 4. Lastly, we alter the equation to find x, which in this case there's no need to. So the answer will be x is equals to 4. Final answer. Okay, so that's it. It's easy if you know how to follow the steps. So let's level up more by solving number 2. Solve for the exponential equation of 32 is equal to 8 to the power of x plus 1. So, first step again, we should make the bases of both sides of the equation equal. What number could possibly be a base of 32 and at the same time a base of 8? That's right, 2. 32 can be written as 2 to the power of 5, while 8 could be written as 2 to the power of 3. So let's rewrite the equation. 2 to the power of 5 is equal to 2 to the power of 3 multiplied to x plus 1. Now that we have made the bases equal, we can now drop it down and equate the exponents. So it will be 5 is equal to 3 times x plus 1. Then let's do the algebra to find the unknown. Distribute 3. 5 is equals to 3x plus 3. Then transpose 3 to the other side, which will make it 3x is equal to 2. Then, through division property of equality, let us divide both sides by 3 to isolate x, which will make it x is equals to 2/3. Now that is the answer for number 2 problem. 2/3. So that's it for number 2. Now, let us challenge ourselves more by solving problem number 3. Solve for y in 1/4 to the power of 2y minus 1 multiplied to 32y is equal to 256. Now, could you recall the rules of exponents? The product rule, quotient rule, power to power rule, zero exponent rule, and negative exponent rule. I hope you have recalled it because you might need some of it in solving this problem. Again, first step, we need to make the bases equal. What base is similar to 1/4, 32, and 256? That's right, 2. So we can rewrite 1/4 as 1 over 2 squared, 32 as 2 to the power of 5, and 256 as 2 to the power of 8. 1 over 2 squared is not yet similar base as to 2 to the power of 5 and 2 to the power of 8, but we can make it by using the negative exponent rule. 1 over 2 squared can be rewritten as 2 to the negative 2. Now to simplify the equation, 2 to the negative 2 to the power of 2y minus 1 could be rewritten as 2 to the negative 4y plus 2 by virtue of power to power rule. Then, combine 2 to the negative 4 plus 2 and 2 to the 5y by product rule. Just add the exponents. Negative 4y plus 2 plus 5y is equal to y plus 2. which will make our equation 2 to the power of y plus 2 is equal to 2 to the power of 8. Now that we have the bases all equal, we can now drop it down and equate the exponents. Y plus 2 is equal to 8. Then transpose 2 to isolate y. Y is equals to 6. And that is our final answer. You see, rules of exponents and properties of exponential equation come handy in situations like this, and it makes our solution easier if we know these rules. Now, let's wrap up what we have learned. First, we have learned the definition of exponential equations. Second, we have learned the rules on exponents, which is the product rule, quotient rule, power to power rule, zero exponent rule, and negative exponent rule. Also, we have learned the property of exponential equations. And lastly, we've learned how to solve exponential equations step by step. That's it for today. I hope you have learned a lot from this video, especially in solving exponential equations. And if you want more video tutorials about other math topics, please follow us on our official Facebook page, Liceo Math Club, and subscribe on our YouTube channel.